figure out what is it exactly that I'm trying to evaluate this for. All right, so if you see an angle like this that you can break apart, we know we're just going to go ahead and apply our formula. So here again, we're subtracting. We notice when we're subtracting, though, for the sum and difference identities, it's basically just going to be applying the same sign throughout. So I can label my sign u and v. And I can just say it's sine of u, cosine of u, cosine of v, right? Yeah. So I could say it's the sine of 4 pi over 3 times the cosine of pi over 4 minus, and then the cosine of u, cosine of 4 pi over 3 times the sine of pi over 4. Does everybody see how I just took that? Because yes?
Did you not put the minus next to the...
No, because remember, you can think about it like this. It's u minus v. So you're plugging in the u and you're plugging in the v. But the minus just kind of tells you which formula to be able to solve and simplify. Is everybody OK with how I just took the formula and basically just plugged in the angles? Yes? No? Maybe? So? OK. So now we just got to simplify. And obviously, by knowing your unit circle, which I've been saying for a long time now, should be relatively simple. Sine of 4 pi over 3. So let's see. That's going to be in the third quadrant. That's going to be a reference angle of pi over 3. So that's going to equal a negative square root of 3 over 2. Cosine of pi over 4 is going to be square root of 2 over 2. Minus cosine of 4 pi over 3 over 2 is going to be a negative 1/2. Because again, 4 pi over 3, guys, is in the third quadrant. And then sine of pi over 4, which is going to be square root of 2 over 2. OK, so if you struggle with the unit circle, you kind of get exposed again. Now, there's a couple different ways we could do this. Do you guys see that they both kind of share a square root of 2 over 2? Yeah? So typically, rather than multiplying this out, which is fine, you couldn't multiply it straight, you can multiply this out, and then, or I also like to sometimes just look at it as factoring out a term that they kind of have in common. So since they both have a square root of 2 over 2, let's factor out square root of 2 over 2. And by factoring out square root of 2 over 2, I'm left with a negative square root of 3 over 2 plus, that turns into a plus 1/2. And then obviously these could be combined. So the square root of 2 over 2. And therefore, let's rewrite this as 1 minus the square root of 3 over 2. Oh, wait, yeah, OK. No, wait a minute. Yeah, because that would be in the fourth. OK? Or another way, you guys, again, you could also just multiply this. Let's just say if we multiply this, so I'd have a negative square root of 6 over 4 plus this would be a square root of 2 over 4. I don't know. The answer choice might look like this. The answer choice must look like that. It's probably not going to look like that one. But it's probably going to be one of these two. So it really kind of depends. I mean, you just need to know, you just need to understand how you can manipulate equations using algebra. It could be factored out. It could be multiplied through. Or there's other things they could do. They could also factor out a 1/4. Factor out a 1/4, you're left with negative square root of 6 plus square root of 2. I don't know how things are going to be represented. But you need to understand how to algebraically kind of manipulate these different equations. OK? I'll say for a test or quiz by mine, I would probably leave it. Oh, and actually, or you could even have something written like this. Or I could also have these combined. Negative square root of 6 plus 2 over 4. And actually, that is the way that I typically like to write them. So if you guys at least know how to multiply them and then get common denominator, I typically like to have it written as one denominator. So that we'll put it to that. Let's simplify this. That would be the way that I would like you guys to